Who jumps out of perfectly good airplanes in the name of science? Mr. C.
Well, Monday's here already, so happy Monday to you, and a bunch of things to do today. So first, I'd like to, of course, remind you to take out your journal. So out it comes, and then 7th graders, your homework is going to come up in just a little bit. So we will stick that in your lesson planner. Just want to remind you about SSRs. When I was out at school over the weekend, I picked up a few SSRs. Now, you've got 2 more months to work on this. So all I ask is that you give me 10 neat, complete SSRs. So use most of the space. I've given you 2 lines each. You don't have to get real picky about the date, just roughly when did you experience that, and just a little brief bullet fact description of your SSR. Okay, now pick out some good ones. Pick out some good ones. Not, like, oh boy, I just have really enjoyed breathing today. It's an SSR. I admit it, but pick some good ones, please, if you would. Okay. So, good news on the snow in the high country. We got more snow up there. Later in the week, it's supposed to warm up into the 90s already, low 90s. Remember, lion, lamb, March comes in like a lion, goes out like a lamb, starts to smooth out, temperatures go up, and fewer storms. A jet stream goes north, and we just don't get precip starting to drop down over us. I'm still praying for that doozy 3-footer in the high country, so you keep praying for that too. We've got a test on Thursday. I'm going to review what that test is going to include. So, and I'll do that in just a minute, but first, let me do this. It'll take a minute. Pardon me. Let's see if I can find this really quick. So, and it will take me just a little bit of time to do this. So I wanted to go over your March 12th test. So here it comes. And I am almost there. So and here's part of it. You had to list 2 of the divine designs of the snow leopard. So besides its great camouflage, many of you put down the large paws, which act like snowshoes kind of. It's got an extra long, heavy tail for balance. It's very quick. It has wide nostrils for getting more oxygen into high altitude, and so on. So anyway, bunch of things like that. Creation, evolution, just the pillars. Fossils, old age, accident, mutations, natural selection, and Big Bang issues. By the way, this Thursday's test, I'm going to ask you again for the fossil pillars, so you'll want to review it. So, and I'm going to put all these things up to review. I'm going to stick them into Tuesday's homework notes. So I'll list all the topics there. So, and actually they'll be up tonight, really. So you'll have Monday, Tuesday, Wednesday night to study, and then the test itself on Thursday. Okay, next, let's see what I've got. The fossil pillar data is also strong evidence that the Great Global Flood killed and buried all of the human, animals, and plants very rapidly. So, number 18 on here, what's the one word for the idea that the universe and all life in the universe, supposedly, it didn't, slowly and gradually over billions of years changed into what they are today. That's the evolution idea. Except the problem is the mechanisms for evolution. More on that shortly. Give two evidences from the O pillar that the Earth can't be billions of years old, but it's probably only thousands of years old. Well, here's one of them. The sediment layers on sedimentary rock, like sandstone, the sedimentary layers don't have erosion between the layers. They're just smooth. Well, if you had a layer of sedimentary rock exposed to the environment for thousands of years, it would have eroded away and there'd be bits and bumps and it wouldn't be smooth. And that's not what we find. We find smooth layers laid down rapidly. So that would be one. Here are some others that, for instance, not that old, not billions, but much younger than that, thousands most likely. So comets keep coming back. They should have all melted a long time ago. The Earth is too hot. It should have leaked out its heat, internal heat. The moon the same way. So rocks on the Earth have too much gas and water in them. It should have leaked out a long time ago if they're millions and billions of years old. And then another one of my favorites is the faint sun idea. If the sun's billions of years old like it's supposed to be, like the solar system is supposed to be, it would have lost a lot of its light and it wouldn't be as bright as it is now. I'll try it one more time. The sun actually, as it is now, is too faint. It would be much bigger and brighter. There, I got it. Okay, so it's too faint. It would be much brighter if it were billions of years old. All right, let's see. Since there's science evidence that Earth is only thousands of years old, means evolution didn't have time to happen. Two scientific laws that show the universe and that life on the Earth couldn't have evolved. The law of biogenesis, which is the law of life. It takes life to make more life or reproduce life. So some people put down law of biogenesis and law of life. Well, I can't give you a twofer on that. The other main law was the law of cause and effect. Mutations are supposed to be a great way to change living things from one kind to another. But wait! It's not possible for mutations to be a great mechanism because they're rare, harmful, and even fatal in most cases. So, you'd have to wait around trillions of years to get billions and billions of good, beneficial mutations. It's just a terrible mechanism. And then the other mechanism, natural selection, it doesn't make things change. If something does change in an environment and it's drastically different than all of the members of that kind, what does natural selection do? Now, natural selection is just a natural process. So what happens is then living things that drastically change and are unlike the rest of their kind are eliminated. They die off. So it doesn't make change, it gets rid of change. What's supposed to work along with mutations to cause the billions of changes? Natural selection. Two science evidences that the Big Bang couldn't have formed the universe and all life in it. Well, where did the particles come from? There's no answer for that. Why would the particles attract? They don't have enough matter. Evolutionists go, don't trouble me. Well, we need to trouble you with that. So that question's got to be answered. Where did the matter come from that formed the Big Bang? Well, it just somehow, no, that doesn't work. So where did it come from? Why would it attract? So why are objects in the solar system and in the universe that we can see rotating? Why are they rotating? There wouldn't be rotation. Just it would be a explosion like that, and things wouldn't bother to stop and rotate. Just laws of physics, that doesn't make sense. And then also The other big thing is explosions don't cause order. They cause disorder, randomness. It's just not a good thing, the Big Bang. And the best evidence of all that reveals that God made everything. And it is, you could use DNA. That would be a good one. The human body, that would be a good one. The Higgs field and all of that particle physics stuff, there's just too much order. It's too much evidence of design, fine-tuning. So, hey, back to the old age question. I forgot to tell you two of my favorites. Well, why is it that dinosaur fossils still have, not all of them, but some of them have DNA? It would have all decayed in a few thousand years. Or they've got red blood cells. They would have broken down in a few thousand years. So, anyway, that doesn't make sense. So I wanted to share all those guys with you and on your test. Okay, so other things that are going to be on the test, how are we doing time-wise? I'm going to give you a little bit of time for your homework, and I've got a video that I've been trying to show you, a divine design video, so I'll get to that in just a minute. So other test things for you guys for 7th grade on Thursday: layers of the earth, crust, mantle, outer core, inner core. And I'll ask you again, why is the outer core? It's super hot. It should be melted. It should be magma, liquid rock, but it's not. So actually I'm talking inner core. The inner core, super hot, should have melted, should be liquidy, should be magma. Why not? Because of the great pressure of the layers above. The outer core, the mantle, and the crust pushing down on the inner core, preventing it from becoming a liquid. So layers of the earth and all that kind of stuff. Mineral characteristics, I'll ask you that. What are the major mineral characteristics? NICCS, naturally occurring, not man-made, not synthetic. So inorganic, so not from living things. That's why coal is organic. It's from plant material. It's buried by the flood. So inorganic, unique chemicals, one of the C's, unique crystals, solids, S, solids. NICCS, naturally occurring. I'll ask you this. Here's 5 points on your test on Thursday. Naturally occurring, inorganic, unique chemicals, unique crystals, and solid. So all of those. Then I'm going to ask you the matter stuff. I'm going to ask you for the 6 elements. So I'm going to ask you for those and their symbols. So you've got the 2 on the sun, right? Hydrogen, H, helium, He. So you've got those. You've got the 2 in our atmosphere, Earth's atmosphere. O for oxygen, O2 actually, 2 atoms of oxygen. And then you also have N, nitrogen. Our atmosphere is mostly nitrogen, about 78%. And then you've got C, carbon, found in our living tissues. And then we had Fe for iron. So those are the 6 that I'm going to ask you about. I'm going to ask you what is the smallest part of an element, and what is it? It's an atom. I'm going to ask you what is the smallest part of a compound. Remember, you've got element, compound. Smallest part of a compound is a molecule. Have you got this in your journal? You got all this in your journal? So while you've got it out and checking, molecule, molecule, the smallest part of a element, compound. Smallest part of a compound, molecule. Again, the smallest part of an element is an atom. So kind of dial those in. Make sure you've got those dialed in. Atom, smallest part of a compound, molecule. Okay? So, about how many different elements are there? A little more than 100 that Jesus made, the building blocks of all matter. So, all of that. What is the best model of an atom? Well, the electrons are moving around so fast, it makes it kind of cloudy, hard to see into the center. So a cloud. So best molecule would be a cloud. The center of an atom is a nucleus. So the center of an atom, we'll just show it to us. Okay. The center of an atom is a nucleus. There's the nucleus. The center of an atom. And then what else? The particles that are found in the nucleus. Positive protons and neutral neutrons. There they are. The two found in the nucleus particles, protons and neutrons. Now, they're also known as one of the fundamental particles. Protons and neutrons are both called quarks, right? Three of the fundamental particles, quarks. So, and then you have electrons that are orbiting the nucleus super fast. So electrons orbiting, protons and neutrons in the nucleus. I guarantee you I'm going to ask you all that. It's just going to happen. So I'm telling you what's on the test. I'm telling you, thanks, Mr. C. So this should be a great score for you this Thursday. So the week that we celebrate the resurrection, later in the week, I'm going to tell you scientific, historical proof that Jesus rose from the dead. Critics who are atheists tell you Jesus rose from the dead because of the evidence. Really? Critics? Yeah, because the data is so great. I'm going to show you the guy who goes over the evidence that Jesus rose from the dead. The historical critics say he had to rise from the dead. I don't believe that, but I have to believe it in a way because of the facts, the evidence, the data. So it's weird. So I don't choose to believe that, but the evidence is there that he did. So anyway, I'm talking about critics who are atheists. So I choose to believe he rose from the dead. So I was in his empty tomb this time last year in Jerusalem. So he's not there. So I'll explain more later in the week, probably Wednesday. So evidence for the resurrection is so awesome and so cool. You never have to doubt whether Jesus came back to life and whether he's a fantastic candidate to be our Savior. Oh yeah. Oh yeah. Coming back to life too, that's pretty good qualifications. Yeah, when you're dead. Yeah, pretty good qualifications. Okay, so what else am I going to ask you? Let's see. I'm going to ask you, what is the name of electrons, the group they're in? So these are the three fundamental particles. So there are quarks, as I already said. Protons and neutrons are in that category. There are leptons, of which electrons are in that category. So, and they're called, both of those, quarks and leptons, are called fermions because they make up matter, the fundamental particles of matter, anything that has weight and takes up space. Are you probably going to ask us what matter is? Yeah. Okay, anything that has mass and therefore weight and takes up space or has volume. So two qualifications for matter: have mass, therefore have weight, and then take up space, or have volume. Okay, so I'll go over that. I'm going to ask you this. I'll show you this. I'm going to ask you what is the chart called that has the fundamental particles on it. There you see quarks, and you see leptons over on the left side. Quarks and leptons, and the different kinds of quarks. Remember that neutrons are made of, because there's only one U in neutron, only one up quark and two down quarks. Protons have two up quarks and one down quark, which makes them different. So anyway, I'm going to ask you, why do quarks attract each other, particularly the protons? It has to do with the kinds of force, so I'll get to that in just a little bit. So, in fact, I'll get to that right now. The four kinds, or four forces, I think I've got these, the four basic forces, here they are. The four fundamental forces: gravity, the electromagnetic force, opposite charges attract, like charges repel, and then you have the strong force, and the strong force overcomes the repulsion force that protons have for each other. Protons shouldn't hold together, matter shouldn't hold together, no matter should hold together. Shouldn't be anything holding together. No objects, period. But because Jesus created the strong force that overcomes the repelling force of the like-charged protons, an atom holds together. And then you have the weak force, which is responsible for fusion on stars. We're kind of excited about fusion on the sun. If it didn't happen, we are an icebox here on Earth, and we are dark as. So life couldn't live. So anyway, all of these forces are fine-tuned. Their amounts are very specific. Fine-tuning. Evidence that God created these forces and make them operate over different distances. The right distance, the right mathematics as far as how strong they are or not. So, good stuff. And then, Mr. C, were you going to show us? I was going to show you, I think I've got it. Where is it? There it is. And I just want to remind you about the LHC, the Large Hadron Collider. And why is it called large? Because it's massive, it's huge. You see this one guy on this lift. You're only seeing part of it, so it's large. It's like 16 miles around underground. Hadron, because it deals with smashing protons into each other. Protons are a kind of hadron, so are neutrons. So it's an atom smasher or particle accelerator. So, pardon me. So it's the LHC, Large Hadron Protons Collider. It causes protons to collide and then they break apart. What's the purpose of them? To break protons apart and to learn about even smaller particles. So it's how quarks were discovered and some of the other particles. So I'll ask you about that. So all of that information, and also review it again. And then here's what I want to do. Your homework is on page 47. Just read it, and then on a sheet of your own paper, write a definition for the 3 kinds of rocks. SIM, you've got sedimentary. So sedimentary rocks. Igneous, they are magmatic rocks made of magma, liquid rock, and then they cool. That's why igneous. And then the last one that you have, it is SIM, metamorphic rocks. Metamorphic. They start off as one kind of rock and are heated and squeezed. Metamorphic. And are heated and squeezed and change into a second kind of rock. So SIM. I want a definition for each, please. Read page 47. This is on RenWeb in homework notes for Monday. Read page 47 and give a nice definition for each of the 3 kinds of rocks. SIM. All right, finally, I want you to look at this Divine Design video on a baby gray whale that's coming over to this boat down in Mexico, where the gray whales migrate to. Mama gray whales head down there to have their young so they can be born in warm water, put on a lot of fat, and grow a lot of baleen so they can filter the food they eat up in Alaskan waters. They actually scoop up mud from the shallow ocean and then squirt the water with the mud and the little organisms in it. Squirt it out. It goes out between the baleen and the little animals stay behind, and lunchtime. So they have to have these baleen filters for filtering out the food they eat. You're about ready to see the baleen. It's really cool to see them. And in fact, one of the people on this raft is actually going to touch the baleen. So have a look at this video. I think you're going to find it pretty awesome. And I will see you on Tuesday. So without further ado, have a look at the baby gray whale. Thank you, Mr. Phil.